Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 6.4, example 4, and it can be found on page 269. So today we're not learning any new material. We're going to be applying what we've already learned. We've learned linear and nonlinear functions from a table, what they look like, linear and nonlinear functions in a graph, what they look like, and linear and nonlinear functions in equations, what they look like. Today we're going to apply that to real life situations. So let's take a look at this real life situation. Account A earns simple interest. Account B earns compound interest. The table shows the balances for 5 years. Graph the data and compare the graphs. So account A is simple interest. Account B is compound interest. Here's our years. Okay. So let's go ahead and copy that down. So we have years, which is represented by T, time, 0, 1, 2, 3, 4, 5. We have account A, which is simple interest. So we start with $100, and then every year we gain $10. Then we have account B, which is compounded interest, which means the next year's interest is based on the year before. So the interest here is based on this $100. But now the interest here is based on the $110. So we're earning interest on that $10 interest as well. Now, here, the interest here is based on this 121. So we're earning interest on the initial $100, but on this $21 as well. So the interest is compounding. Okay, so here's the table that the book has given us. Years, account A is simple interest, account B is compound interest, and they wanted us to graph this and compare the graphs. Okay, sounds easy enough. Okay, since I don't have any negatives, I'm not going to be working in any of the negative spaces. I only need the first quadrant. So my graph is only going to have the first quadrant because I don't have any negatives. So my X is going to be years. Right here, this is my X. So I have 1, 2, 3, 4, 5. My Y axis is going to be dollars. And we're going to start with 100, 110, 120, 130, 140, 150, 160. So we're going to graph these bad boys. So first, let's graph account A, simple interest. 0 years, $100. 1 year, $110. 2 years, $120. 3 years, $130. 4 years, $140, and 5 years, $150. So when I look at this, that graph looks pretty straight to me. It looks pretty linear. But just to confirm that this is linear, that it is straight, I'm going to check my rate of change here. So plus 10, plus 10, plus 10. And it looks like I have a pretty constant rate of change. My rate of change is plus 10. So the book asks us to describe the graphs, to compare the graphs. So when I look at this, I can see that it is positive, or that the amount is increasing. I can see that I have a constant rate of change. And that means that my graph is straight, which means this is a linear function. Okay, now let's graph account B that has compound interest. So we have 0 and 1. So at 0 years, we deposit $100. After 1 year, we have $110, just like account A. But now this is where we start differing. After 2 years, we have $121. After 3 years, we've got $33.10. After 4 years, we have $146. And after 5 years, we have $161. When I look at this, that line doesn't look very straight to me. It looks like it kind of curves. But just to be sure, I'm going to check my rate of change. Plus 10. Plus 11. Plus $12.10. Plus $13.31. Plus $14.64. This is not, there is a pattern here, but it is not a constant rate of change. It's not constant. My rate of change varies. So I can see that my graph is still positive. The amount is still increasing. But I do not have a constant rate of change. So if I look at my graph, I can see that it is curved, which means this is a non-linear function. And this is real life. People like, when are we going to use linear and nonlinear functions? Well, banks use them every day to determine simple interest versus compound interest. How does this affect you? One of these days, I hope you plan on retiring, you know, get a job, get a career, you're making money, you're setting money aside so that one day you can retire. You want to be working with compound interest because you make more money quicker than simple interest. So here's an example of a real life application of linear versus non-linear functions. Okay, the math is real. So let's do another one. Let's do another example. Okay, the book is going to give us this table. So the year again, which is time, 0, 1, 2, 3, 4, 5. We have account A, which is simple interest. We start with $50, and every year it grows by $5. Simple interest. Every year it grows by $5. It's guaranteed. Then we have account B, which is compound interest. We start with $50, just like account A. And after 1 year, we have $55, just like account A. But now we're earning interest on this whole amount, this $55, not $50, but the $55. And you can see we've got 50 cents more. It doesn't look like that much. It's not that big of a deal. But over time, it does become a big deal. So after 5 years, we've got more than $5 more than account A. And this here is a small amount of money. You're thinking $5, yippee skippy. But what if this is your retirement and you're talking about tens of thousands or hundreds of thousands of dollars? This could be $500 more or $5,000 more or $50,000 more. That's a lot of money. So compounded interest is kind of a big deal. So let's graph this and see what we've got. So here's my x-axis. This is the year. And I've got 1, 2, 3, 4, 5. My y-axis will be the dollars. And let's go with 50, 55, 60, 65, 70, 75, 80. So let's graph these guys. So account A, simple interest. After 1 year, we start with $50. So at 0 years, we're starting with $50. After 1 year, we've got 55. After 2 years, we've got 60. After 3 years, we've got 65. After 4 years, we've got 70. And after 5 years, we've got $75. When I look at this, it looks like it's a pretty straight line. So let's take a look at our table just to confirm our rate of change. Oh, look at that. We have a constant rate of change. It increases by 5 every year. It only increases by $5 every year. That's the same. That is constant. So what can we say about graph A? It is positive, or the amount increases. We have a constant rate of change proven right here. I mean, this looks like it's a straight line, but we just proved it with the table. So that means our line is straight. Our graph is straight, which means we have a linear function. Now let's graph the second account, account B, compound interest. So we're starting with $50. And after 1 year, we have $55, just like account A. But now, after 2 years, we've got $6.50. Not that big of a deal. After 3 years, we've got $66.55. After 4 years, we've got $73.21. And after 5 years, we have more than $80. So to look at this, it is a curved graph. It doesn't look linear. It doesn't look like a straight line. It's curved. But I want to be sure. So I'm going to check my rate of change. So here I have +5. Oh, right here, +$5.50. +$6.05. I can see that my rate of change is not constant. My rate of change is changing. It's not the same. It's not constant. So that confirms that this is not a straight line. It's curved. So what can we say about account B? It's still positive. The amounts are still increasing. But I do not have a constant rate of change proven by the table, which means my graph is curved, which means this is a non-linear function. So once again, linear versus non-linear. Banks use it every day. And I mean, there's plenty of applications here, but this is the difference between linear versus non-linear, and it does affect your life. So if you're doing this and you're thinking, when am I ever going to use linear versus non-linear functions? This is dumb. Why do we have to learn about this? Well, it has a very real application to your life, especially if you plan on retiring sometime. Okay.